Hello students, here the second chapter from our second section mathematics of standard 12. The chapter is applications of derivatives. Second chapter is applications of derivatives. So what are the applications of derivative? We have to learn these three applications of derivative from this chapter. The first application is tangent and normal, which is nothing but geometrical application. The second application we have to learn is increasing and decreasing function, means for given function, if the given function is increasing or if it is decreasing. The third application is maxima and minima, means we have to find the maximum value of that function, we have to find minimum value of that function. These are the three applications. Now we will start the first application, that is the application of derivative to find tangent and normal, to find equations of tangent and normal to the given function. Suppose we have to find tangent and normal to the given function y is equal to f of x at some point x1 y1. Let x1 is equal to a. Suppose constants are given, generally we denote the constant by a. So x1 is a and y1 is, of course, it will be f of a, since our function is y is equal to f of x. So this is the order pair at which we have to find equation of tangent to that function y is equal to f of x. Remember, if we draw the graph of the function of this given function and if we consider this point on that graph, then at that point you have to draw the tangent and normal. You have to find equation of tangent and normal to that point. Now first of all, let me clear what is tangent. Tangent is nothing but is the straight line which touches that curve, which touches that graph at a point, at a single point only. That is nothing but tangent. And what is normal? Normal is also a straight line. Normal is also a straight line which is perpendicular to the tangent. Normal is also a straight line which is perpendicular to tangent. So every time, first of all, we will find the tangent of that curve, and using tangent we will find normal to the curve. So for that, if tangent and normal are the straight lines which are perpendicular to each other, then there is some relation in between their slopes, and that will help us to find their equations. Okay, so first we will find slope of the tangent. Using slope of the tangent we will find slope of the normal. They are perpendicular to each other, therefore the relation between their slopes is nothing but product of their slopes is equal to -1. We will use this fact. Okay, so first of all, consider this curve at the point x1 y1, that is a, f of a. Now what are the steps to find the equations of tangent and normal? So let us come to the first step. Stepwise we will write those facts and then we will solve the examples to obtain the equations of tangent and normal. So the step first, what is the step first to find the equation of tangent and normal? Remember students, if you go through those steps, then you will easily find the equation of tangent and normal. There is no doubt. Okay, so first of all, step first, as usual, as it is application of derivative, so we will find derivative of this function in the step first. So find dy by dx, that is derivative of y with respect to x, that is nothing but f dash of x. This is your first step. Then there is step second. Step second is there, find value of this function, value of this derivative at this point x1 is equal to a and y1 is equal to f of a, since we have to find tangent at that point. Okay, so the second step is to find value of this derivative f dash of x at the point a, f of a, that is x1 y1, where we have to find the tangent. Okay, so this is your second step. Now this step will give you the slope of the tangent. This value will nothing but slope of the tangent, which is slope of a required tangent, which is slope of a required tangent. This is nothing but slope of the tangent, and we denote it by m. Denote it by m, small m. Slope of the required tangent, and denote it by small m. Denote it by small m. Okay, slope of tangent is obtained. Similarly, in the same, immediately find slope of normal. Therefore, slope of normal is, slope of normal, let us denote it by m dash. M dash is equal to, we know normal and tangent are perpendicular lines to each other. Therefore, product of their slope is -1, means slope of normal is nothing but negative reciprocal of slope of tangent, or slope of tangent is nothing but negative reciprocal of slope of normal. So what is slope of normal? This will be -1 upon m. This will be -1 upon m. So in this step, second step, we found the slope of the tangent as well as slope of the normal. Okay, now step third. Step third is that in step third, we actually will find equation of tangent and normal. You know how to find equation of any straight line if its slope is given and one of the point on that line is given. Remember which form we have to use to find the equation of line, to find the equation of tangent? If we know slope of the line and if we know a point on that line, then by using point normal form we can find equation of the tangent. By using point normal form we can find equation of the tangent. Now what is point normal form? It is simple. If x1 y1 is any point on the line, if m is slope of that line, then we know that equation of that line by using point normal form is y minus y1 is equal to m into x minus x1. So our step third is find yes, equation of tangent as well as normal. Equation of tangent and normal also by using point slope form. Point slope form. Remember point slope form. What is point slope form? That is y minus y1 is equal to m into bracket x minus x1. This is nothing but point slope form, and we have to use this form to obtain the equation of tangent as well as equation of normal. The equation of normal will change by this term only. Its slope is -1 upon m dash. Okay, these are the steps to find the equations of tangent and normal to the curve. Now we will consider some examples related to this. Okay, consider the first application, tangent and normal. We will consider the examples from this application. So the first one, find equation of tangent and normal to the curve x cube plus y cube minus 9xy is equal to 0 at 2, 4. This is the point of contact. Look at the equation once again. What is the curve given? X cube plus y cube minus 9xy is equal to 0 at point of contact is given. It is 2, 4, means our x1 is equal to 2 and y1 is equal to 4. At this point we have to find equation of tangent and normal. Now students, look at this equation. We generally consider the equation y is equal to f of x. It is not in that form, but we already learned about this form. This is nothing but implicit function. This function is implicit type of function, and you know how to find derivative of this type of function. In the first chapter it is evolved. Okay, so we will go through our steps. The first step to find the equation of tangent and normal. The first step is what? Consider this equation and differentiate this with respect to x. So I will consider this equation. X cube plus y cube minus 9xy is equal to 0. We have to differentiate this equation 1 with respect to x. Differentiate 1 with respect to x. So I will differentiate each and every term in this expansion with respect to x. What is derivative of x cube? Using that formula, derivative of x raised to n with respect to x. You know, this is nothing but n into x raised to n minus 1. This formula I will use here to find the derivative of x cube. So this is equal to 3x square plus, again using the same formula, I will differentiate this y cube also, but it is now composite type, right? So first of all, derivative of y cube, using that one, it will be 3 times y square, but I know that y is a function of x. So I must differentiate again this y with respect to x. I will multiply this term again by dy by dx. Now the derivative is completed for this term y cube. Okay. Now minus 9 times x into y. X into y. Product rule should be used there. There is product of two terms and we have to differentiate this with respect to x. Now what is the product rule for a derivative? What is that formula? What is product rule? You know, if y is equal to u into v. If y is equal to u into v. Both are functions of x. Both are functions of x. Then dy by dx is equal to u into dv by dx plus v into du by dx. So we will use this rule. हा फॉर्म्युला आपण यूज करणार आहोत. ओके, इज दिस क्लियर? सो 9 into x into y. First function is x, second function is y. So 9 into bracket first function into derivative of second function with respect to x. Look at this function plus y into derivative of x with respect to x is 1. So our derivative is completed and this is equal to 0, right hand side. So thus the derivative of this function 1 is completed. 3x square plus 3y square divided by dx minus 9 times product rule is used and this is equal to 0. Now look at this term throughout. I can divide by 3. This 3 can be cancelled. So divide by 3 on both sides. You will get x square, therefore plus 3 cancelled y square into dy by dx minus, dividing by 3 it will be 3. I will open this bracket, minus 3 into x dy by dx minus plus minus again 3 into y is equal to 0. Now I have to find the value of dy by dx. So I will collect all the terms containing dy by dx and remaining terms will be on another side. So collecting the terms containing dy by dx and remaining terms on the another side. So right hand side of this function minus 3y, on that side it will be plus 3y and this x square is minus x square. Okay, now this part on the left hand side, take this dy by dx common. So therefore taking dy by dx as common part, remaining part in the bracket is y square minus 3x bracket complete times dy by dx. So I get this y square minus 3x dy by dx is equal to 3y minus x square. Derivative is completed up to this. Now using this I will find dy by dx. We just have to take this term on the right hand side. Okay, y square minus 3x on the right hand side. Therefore dy by dx is equal to 3y minus x square upon this bracket y square minus 3x. Y square minus 3x. Okay, this is the value of dy by dx. So my first step is completed up to this. Now what is the second step? We have to find value of this derivative at the point of contact, that is 2, 4. Point of contact is 2, 4. So therefore dy by dx, value of dy by dx, second step, at which point? At the point 2, 4. This is my point of contact. So value of x is 2, value of y is 4. I will put these values in this equation so that 3 into bracket value of y is 4 minus x square, value of x is 2. So 2 square upon, again y square means 4 square minus 3 times value of x is 2. So simplify this. This is equal to 3 into 4, 12. 12 minus 2 square, that is 8. 12 minus 4, 8 upon 16, 4 square, 16. 3 into 2, 6. 16 minus 6, that is equal to 10. Reduce this by 2. So 2 4s are 8, 2 5s are 10. This is value of dy by dx at 2, 4. And what is this? This is nothing but slope of our tangent. Therefore, slope of required tangent at which point? At 2, 4 is m is equal to 4 by 5. Slope of the tangent is 4 by 5. Okay, tangent is perpendicular to normal. So using this one, we will find slope of normal also. Therefore, slope of normal. Slope of normal, we denote it generally by m dash. That is equals to negative reciprocal of m, minus 1 upon m. So what is reciprocal of 4 by 5? It is 5 by 4. And negative reciprocal, that is minus 5 by 4. Okay, this is nothing but slope of our normal. Slope of tangent is obtained, slope of normal is obtained. Now the last step, third step. Therefore, equation of tangent. How? By which form? Equation of tangent by point slope form. Point slope form. And what is point slope form? Is y minus y1 is equal to m times x minus x1. Remember, we have to find equation of tangent and normal at which point? At 2, 4. So x is equal to 2, y is equal to 4. x1, y1, 2, 4. These x1, y1 are nothing but 2, 4. So I just have to put the value of m, x1 and y1. Therefore, y minus, what is y1? y1 is equal to 4. Is equal to, what is m? m is equal to 4 by 5 into x minus, what is x1? x1 is equal to 2. So this will give me equation of tangent. Now look at this part. Remember, when the value of coordinates, when the coordinates are given, when the point is given, sometimes students make mistake here to put the value of xy or to put the value of x1, y1. Remember, x and y are general points in our equation. So they will never vanish. They will always there. You can't find the equation there. Right? So without x and y, equation can't be there. You can't have the equation. So remember, you have to put the values of x1 and y1. Not for the x and y. X and y are general points in that equation. They will always there, so that equation is there. We always put the values of x1 and y1. So I put x1 is equal to 2, y1 is equal to 4, since my point of contact is 2, 4. Is that clear? So now it is simple. You just have to simplify this equation so that you will get equation of the tangent. Therefore, y minus 4 is equal to, or multiply by 5 on both sides, you will get 5 times y minus 5 into 4, 20 is equal to 4 times x minus 4 into 2, 8. Multiplied by 5 on both sides, 5y minus 20, 5 on this side cancel, 4 into x minus 4 into 2, that is 8. And thus the simplified form, therefore 4x, this 5y, on that side it will be minus 5y, this minus 20 here will be plus 20, so minus 8 plus 20, you will get plus 12, is equal to 0, is the equation of tangent to the given curve at the given point. Is equation of tangent at which point? 2, 4 to the given curve, to the given curve. And now in the same way we will find equation of normal also. It is now simple. So equation of normal, the last one, and equation of normal. Again by using point slope form with slope m dash, so that equation is y minus y1 is equal to m dash into x minus x1. Substitute the values. What is y1? y1 is 4. What is m dash? M dash is negative reciprocal of m. That is, how much is it? I think minus 5 by 4. Minus 5 by 4 into x minus x1. x1 is equal to 2. So simplify this equation. Again multiply by 4 on both sides. You will get 4 into y minus 4 into 4, 16 is equal to, here 4 will get cancelled, minus 5 into x minus plus 5 into 2, 10. And therefore rewrite these terms in standard form. Minus 5x on this side, that is 5x, plus 4y minus 16, and this 10 on this side, it will be minus 10, minus 16 minus 10 minus 26 is equal to 0. And this is equation of normal to the given curve at the given point 2, 4. Is that clear? Got it? Okay, thank you.